Let's go through LeetCode 1058, minimize rounding error to meet target. And for this question, give us a string prices, and each string it is represent the price, which is a number, and also it has target, which is an integer. And for each price, it can round up or round down. Round up, that is floor, right? Round up, that is sale. Round down is floor. And if we can use those price to round to some of the integer and add up to the target, by trying to find the minimal rounding errors. So let's look at this example. We can round the 0.7 to round to the floor, that is 0. And this one, the error is 0.7 minus or 0. And we can also round up this. So the error for this number is 0.2. And also we round up this to 5, right? So this is 3, this is 5, and this 0. And the sum of the rounded value is 8, and the rounding error, sum of the rounding error is this number, right? And we know when this is going to flow, this going to cell, this go to cell, the total rounding error is minimal. So it let us to return the minimal rounding error, which is a string, and we are return this number and convert it to a string. So we know for each number, each price, it can either be round down or round up, or let's say can be sell or flow. So for all of the prices, if we all use a sell function, we'll get a maximum price. And if we all use a flow function, we'll get a mean minimal error, minimal total error, or maximum total error. So the first condition is that if this target should be in the range from the min to max, right? If it's not in during this in this kind of range, target not in this range, we'll just return -1, right? Of course, we need to convert it to string, and this is the first thing we can think about. The second thing we can think about is that if we, for all of the prices, we round up, we use a sell function, we'll get a max number, right? So if the target is in the min to max range, for example, we get a max. So how many numbers we are going to flow? The number to flow, to use the flow, will be k will be max minus target. Let's take the example. If we all use max, right? This will all use sum or sell. This will be 1. This will be 3. This will be 5. So the max will be 9. So how many we are going to use a flow? That is 9 minus 8. So that's the second one. The third thing we want to mention is that how we are going to use the string to calculate to convert to to use a flow those kind of mathematics seem to how can we use those kind of functions? We can use float, right? Float value of a string. For example, price, right? And to convert this to a float, and how we can use a double, right? Double type equals mass dot still to this flow, right? And we can also have the double flow copy mass dot flow. We can use this kind of mass cell and mass flow function to get the double type. That is the third thing we need to take notice. That's the fourth thing we want to say is that for the number like for 2.0 right? When we use the cell function, it will say high. Will be 2.00, and its low will also be 2.000, right? So it is possible for this kind of number, the flow in its cell, it is the same. Okay, so this is the thing we need to take a notice. Let's begin to write the first condition, right? We're going to have int min equals 0, max equals to 0, and for string prices, we'll have float f equals float value of price, and we'll have double flow equals mass dot flow like that, and the double I equals mass dot str flow. So we'll have min plus equal to low, right? And doing like this one will convert to integer, right? And convert double to integer, and max plus equal to high. And so this is the first thing is that if the target smaller than min or target greater than max, it does return this. This is the first thing, and this is the first condition. The second condition is how many we should flow how many number. So we'll use k equals max minus target. We'll flow that number of prices to get the target. And this is our method studies. And what we want is that we are trying to use these kind of prices, different prices, and trying to get the minimal errors. Right? So we can define double type. We call this new double and comes along in the k plus 1. So we don't have an n, right? So we'll have int of price is the length. So we have an actual length for both price and the flip. Okay, we call flow. Okay, flow. what does this kind of function mean? Is that for the DPID J means the minimal error sum, right? Sum error, or just a discount formula. Minimal errors for the previous I prices. Yeah, and we flow K price, J price, okay, flow J prices. So for the previous I prices, we flowed J prices, the minimal errors. So this will be what define this kind of two-dimensional array DP, right? What we are going to return is just a return DP in K, right? That means for the previous n prices, we flip K, we float K price, the minimal errors. Of course, we want to convert this one to string, right? So this will be format. We have some kind of format. Wait, the format for this from double to this kind of stuff is like this way. Okay. Okay, so we'll get the first set the initial value for this. That will be for double D in DP, right? We'll just erase here. D. We know the maximum, it will not this price is positive, right? So we know this diff will not be more than max. Okay, we can just put this down as max. Okay. Of course, you can put something like a double max, but when we do calculation, we need to make sure it is not out of range. You can have integer right shift twice and convert to double, right? And also we'll have EP 0 equals D like this, right? Double like this. So let me work this one as well. So we're going to flip the price, right? The previous for into I equals 1 is smaller than n plus 1. The previous n plus 1, right? Plus. And we are going to have for n to j equals j equals 0. J smaller than k plus 1 prime, j plus plus. And we know for string this price it will be price is I minus 1 because we have a actual index. So we'll have float f equals float value of price and double low equals max dot low and double high equals max dot zero. Right. So we know for the ice for this price, okay. I mean this price, the index I minus 1, right? It have the option to flow it or not flow it, right? So if it does not flow it, then we'll have dp I j equals, then we'll just sell it, right? Get that. Just a round up, right? So we'll have dp I minus 1 and j plus if we round up, that will be high minus low. Okay. So also we have option that we get a round down, that get a sell weight, but since that there is some kind of scenario, for example, this kind of number, the high and the low, the flow or the sell, they are the same, right? So we'll write this kind of condition if first is that the j should greater than 0, right? That means we are trying to have something like compare get a minimal value, right? So we'll have dp I minus 1 j minus 1, right? J minus 1, that is we flowed smaller one we flowed this the price, this price, right? And so the previous one we just flowed one times less, and we'll have this condition, and because this is minus 1, so we should make sure this one greater than 0, and if the high doesn't equal to low, right? We'll have dp I j equals max of mean. So in that case, we can have a mean value, and And also for this one, we're going to flow it. So it will be flow minus low, right? And we'll compare these two, right? And that means we flow one more, flow this price. In the previous, we flow the J minus 1 times, and there is one extra flow here. And this number means we keep the same times of flow with the previous one, right? So we'll compare these two. So this was pretty much our code. Okay. So this is pretty much like the backpack problem. We know every number it is for this ij, right? It will depend on ij, but depend on I minus 1 here, right? I minus 1 j and I minus 1 j minus 1, right? I minus 1 depend on this too, right? So sorry, let me clear this. So this is ij, it will depend on I minus 1 j minus 1 is here, and also ij, right? Depending on this number, right? These two numbers. So in this case, we can convert using one dimensional dp instead of two-dimensional dp to simplify this. Because this one is depending on this two, right? So we know for this j iteration, we should do a reversed loop, right? Still remember that if it is another scenario, we have some other question. This is depend on, if this depend on this, then j we should have a forward iteration. But now our we are dependent on these two, right? So we have to iterate j from the big part to the lower part. So we can also simplify this one to one-dimensional array. Can use this, right? And we just need this. And we'll have dp0 equals 0, right? And price. So we'll have int j equals k, and j greater equal to 0, j minus minus, right? And keep this same. And we'll have this. So in the end, what we're going to return is just dpk, right? Okay, so in like this way, the time complexity will be the price if there are n prices, right? So it will time complexity will be n multiplied by target, right? And the space complexity is that we just have a dp with a target, right? Sorry, not target. That is the k, right? K, how many? The time complexity will be the price multiplied by k. K is the how many we need to flow, right? So actually, this one, this k number is dependent on the price n, right? And also the target. So the time complexity will be n multiplied by k, and the space complexity will be OK, right?